Find the locations of any holes in the function. Now, this is one of my favorite algebra topics, the idea that there can be a hole in a function, or just one point that isn't there. So the way you identify a hole is it's a common factor in a rational function. So we have to factor the numerator and denominator, see if there is a common factor or factors, and then take it from there. So let's factor the numerator, f of x equals, the numerator would be x plus 2 times x minus 2. That's just a simple sum and difference pattern. And then for the denominator, it factors to x plus 4 times x plus 2. Okay, now take a look. This x plus 2, these are in common in the numerator and denominator. There's one here. There's one here. Okay, so what that means is if you have an input of -2, you're going to end up getting 0 divided by 0 for this function, which is undefined. But the thing about it is this is different than a vertical asymptote, because the rest of the function doesn't change when you're approaching -2 from either side. So this is the same thing as saying f of x equals x minus 2 over x plus 4, as long as x does not equal -2. And I would encourage you to go ahead and graph both of these functions on your calculator, and you'll see that there's only a difference at x equals -2. And let me get the calculator and see if I can explain that a little further. So here's the first graph. This is the original function, x squared minus 4 divided by x squared plus 6x plus 8. Have a look at the graph. You can see what it looks like. Now let's show the table of values. And you can see right away there are two error or undefined values. There's -4 and -2. Now let's go back to the graph. That x equals -4, that's a vertical asymptote, and notice how the function diverges away from the x-axis. In other words, decreases and then increases. But the other one, see at -2, it's almost like it's invisible in the graph. You can't see anything here. Well, let me graph that other function that's reduced. So that one is x minus 2 divided by x plus 4. Now look at this one. It overlaps perfectly the other function. So the functions really are equivalent except for that one value that was undefined, or the hole in the function. Now you can see at -2 for x, the first function has an error just at that one value, meaning it's undefined. But in the other function, it's actually defined at -2. But that's what a hole does. It's just one missing point in the function. There's no asymptotes, no funky curves, there's no giveaways here. So when you're graphing it by hand, you just put an open circle over that point where it should be. The location of the hole? Well, the x value is at -2. So you input the -2 into the simplified function and see what you get for an output. So it's going to be f of -2 equals -2 minus 2 over -2 plus 4, which equals -4 divided by 2, or -2. So this hole is going to be at -2, -2. Okay, so that's how you find the hole of a function. Factor it out, look for common factors, and then you find the value that makes that factor equal to 0. That value is going to be the x value for the hole. Then you simplify the function, find the input and input the value for the hole to get the output, and there you go. That's your hole location right there.